These notes are going to go with your learning target that goes with your nuclear learning targets. So this first chart here, this goes with your radioactive particles, so make sure you write these down in your notebook. An alpha particle, sometimes you'll see it written like a fish. This is the typed font. An alpha particle is a helium nucleus, so you'll also see it written like this, and we'll talk about this in a second. Basically, there are 2 protons and 2 neutrons. It does have a positive charge, and these are the weakest of the radioactive particles. The beta particles are high-speed electrons that are emitted from the nucleus when they're created, because remember that electrons can't be in the nucleus. So because it is an electron, it has a -1 charge, and these are a little, they're still weak, but they're a little bit stronger than an alpha particle. An alpha particle can be stopped by a sheet of paper. Beta particles need a little bit more to be stopped, but they can be stopped by like a book or your skin or something like that. Now gamma particles, you might see the gamma symbol written like that as well. These are the high energy X-rays, and these are the strong ones. These are the ones that you always want to be careful with. They're the ones that cause cancer, you know, and they're also the ones that they use to cure cancer in radiation therapy. So these are the 3 major particles that we're going to see when we talk about nuclear chemistry. Now, when we balance nuclear reactions, you have to balance by both the mass number, remember is A, and the atomic number, which is Z. So down here you see this element, the isotope symbol, so remember that mass number is A and atomic number is Z. Alright, and remember that the atomic number is what comes from the periodic table, tells you what this element is. Remember the mass number is protons plus neutrons. So this neutron to proton ratio, we'll get more into that a little bit later on, so you don't have to worry about that right now. But this is just some review of things that we have done on how to calculate your mass number and your number of neutrons. Now, alpha decay is where a radioactive nuclei emits an alpha particle. So what happens is you start, let me change colors. You start with radium-226. All right, and I'm going to put this alpha, if you know that this is alpha decay, I'm going to put the alpha particle over here. So what needs to happen here is that your numbers need to add up, okay? So something plus 4 has to equal 226. So of course that is 222. All right, and something plus 2 has to add up to 88. So of course that's going to be 86. And then we look on the periodic table and we see that the element with the atomic number of 86 is radon. So in an alpha decay, you will lose an alpha particle, and then you can determine what the other element is based on how the numbers add up. So an example here is what element is formed when polonium-214, which is written like this, a radioisotope undergoes alpha decay. Give the atomic number and the mass number of the element. So if we start with polonium-214, that decays, so decay is arrow, and it's alpha decay. So we know that it gives off an alpha particle. Now the only reason I wrote the other one over here was because that's the way it was written in the diagram. Doesn't matter what order. So what plus 4 is going to give me 214? That's going to be 210. And what plus 2 is going to give me 84? That's going to be 82. So the element that has an atomic number of 82 is going to be lead. So this is your product of an alpha decay of polonium-214. In a beta decay, you're going to give off a beta particle. So in this case, we have iodine-131 gives off a beta particle, and we end up with xenon-131. So the way we would write that would be, here's our iodine, all right, and our beta particle. Now I use the Greek symbol, they use the B. You're going to see it both ways. Okay, so what plus 0 gives me 131? Well, 131. And what plus -1 gives me 53? That's going to be 54. So on the periodic table, the element that has atomic number of 54 is xenon. So xenon 131 is what is formed by the beta decay of iodine 131. So you may have a problem like this. What element is formed when iron 60 undergoes beta decay? Give the atomic number and the mass number of the element. So if we start with our iron, all right, and we're undergoing decay, and it is beta decay, now we need to fill out the rest of this. So what plus 0 gives me 60? What plus minus 1 gives me 26? So I'm going to use my bottom number, it's my atomic number, and that would be cobalt. So cobalt 60 is my answer, and the atomic number and the mass number are already written on here. Now a couple of other types of radiation you may see, but you're not really going to be tested on. There's electron capture, where an electron is added to an isotope and you get an X-ray or a gamma ray photon. And then there's also positron emission. A positron is very similar to an electron, but it has a positive charge instead of a negative charge. But like I said, these are not ones you would be tested on, but you may see them from time to time. Now you might also see a problem like this, where you would start with an isotope of, well, here we go again, me and my technology. Let's start with that cobalt 60 isotope. All right, and let's say that you get manganese 56. What type of decay would this be? All right, well, we have to work backwards. So what plus 56 gives me 60? That's going to be 4. And what plus 25 gives me 27? That's going to be 2. So you can see here that 4 and 2 tells me that I have helium. So this particular problem is an alpha decay. So you may have to figure out the type of decay based on, filling in the blank. But all you have to remember for these is that all your numbers should add up, and then be familiar with your different particles so that you can identify the type of decay.